Thank you for joining the June 2023 VMware TAM customer webinar. This webinar is organized by the TAM organization so that you, our TAM customers, have the opportunity to hear great content about all things VMware, interact directly with subject matter experts, and get the full benefit from your software. Please make use of the Q&A feature to ask any questions. And if your question doesn't get addressed today, be sure to reach out to your TAM and ask them to follow up. Just a few announcements before we get into the content. Our next TAM customer webinar topic will be on VMware Horizon virtual desktops and applications and how those run in a hybrid architecture. Specifically, we'll be going over how VMware deploys and operates various on-prem cloud capabilities and federates them, to work together as a unified, globally spread deployment. This session is scheduled for July 20th, and your TAM will send you all the details for that. Again, we want you to benefit from these sessions by interacting with the speaker. So if you have any questions during today's webinar, please use the Q&A feature. And at the end of today's session, you'll be prompted to fill out a survey. Completing this survey will help us understand the value you receive from this session, and it also provides you with an opportunity to give us suggestions for future topics. We greatly appreciate your participation in that survey. And lastly, this webinar is being recorded, and your TAM can make the link available to you. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. With that, on to today's speaker and topic. Nicolas Bayle is a network and security technologist in VMware's AVI product marketing management group. He's also an author on the VMware blog. That's blogs.vmware.com, where you can find more great content on NSX ALB and a few other topics. Today, Nick is joining us to go over how you can leverage NSX ALB to deploy, secure, and scale your apps on-prem and in the cloud. Nick, thank you for covering this topic and for joining us. I'll hand it over to you.
Thank you, Chris, and thank you everyone for your attendance here in this TAM webinar. And it's my pleasure to lead this webinar today. And as you mentioned, Chris, the title of this webinar today is NSX ALB, the glue between your infrastructure and your applications. So today, I don't have a lot of slides, actually. I have just few slides, but I want you to understand what we are talking about. I mean, you all have a specific infrastructure. Maybe you have 1, 2 data center, maybe you have one type of cloud, maybe you have many type of clouds. And basically, those infrastructures, they live because of the application. And if you want your business to grow, you need more application. You need your application to be scalable. You need your application to be secure. You need your application to be reliable. And of course, you need to be able to troubleshoot your application very efficiently. So today we are going to talk about those applications. And as you can see in this slide here, you have some figures which shows you that how the number of applications increased over the past years. So you see this number here. In 2021, we were talking about 195 million of applications. And see the forecast for 2025. It's about 750 million of applications, right? And it's not only about the number of applications. Think about the location of those applications. Maybe a few years before, you had only applications relying on physical servers and virtual machines, but nowadays, you know how the modern applications, they are built. They rely on containers. They rely on microservices. And one of the outcomes of this is definitely that now for one big application, it's like many small applications that you have to manage, that you have to secure, to scale, to troubleshoot, etc. Right? And because of this change of architecture, you need to manage those applications at scale. And this is very challenging. Plus, now you know that we are living in a multi-cloud environment. So your organization, maybe you have application in your on-prem environment, I don't know, vSphere or whatever you are using here. but we know that you have also application in the public cloud, because those applications, they require to have new features like analytics and visibility and AI and machine learning, all the technology that you know today, right? And you end up having those applications on-prem, on the public cloud, and you need to manage those applications. Plus, now there is a need to make sure that automation is everywhere to manage those applications. Let's say you have an application team. This application team release a new application. They do the Git commit on their GitHub account, and all of a sudden they expect that you guys at the infrastructure level, you can have this application online in a matter of minutes, right? So we see that this landscape is evolving. We see that we have many applications to manage. The nature of the application has changed from bare metal server to VM and nowadays to containers. And we see that there is a need to make sure that those applications can be online in a very fast way. So the idea here is to talk about application and to see how you can somehow glue those applications with your infrastructure. So maybe you are using the VMware stack, on-prem, vSphere, vCenter, ES6i, NSX, all the stacks that you know, right? And that's very good because this basically gives you the capability to virtualize the compute, virtualize the storage, and virtualize the network. But what is the link between this infrastructure and your application? Well, actually, it is something called an application delivery controller. Other people, they call that a load balancer. Or maybe if you come from the Kubernetes world, you call that an ingress. Anyway, you get my point. The point is that you need to have something to manage your application. You need to have something to make sure that those applications, first, they are online. You need to make sure that your application, they can scale. You need to make sure that you can troubleshoot your application. So you need to have a modern load balancer. Why? Well, if you are still using a legacy load balancer, you're gonna have some problems. Why? Because first thing, you need to automate everything, right? And when it's about automation, if you are using a legacy load balancer, something like an F5 big IP or NetScaler, it's going to be complicated to automate. Why? Well, because to do the application delivery, first of all, you have many products. If it's about doing local load balancing, you have one product. If it's about doing GSLB, you have another product. If it's about doing this in a Kubernetes environment, you have another solution. It means more licenses to manage. It means more devices to troubleshoot. It means more API to automate. So just for an automation perspective, it is very complicated. What about the utilization? Are you guys using your legacy load balancer in a very efficient way? Well, you know how it works. Those legacy load balancers, they have been designed like 20 years ago. So they are still using the same architecture. And if you know a little bit about that, you know that they have an active load balancer and a standby load balancer. So what you are seeing in this slide is basically you're going to use this at 20, 15% of their capability, of their capacity, right? That's another point where it's not very fully appropriate for a modern application. Plus, remember, I've told you are still using this active standby appliance. Well, we live in a world where everything is elastic. What are you looking for when you send your application in the cloud? You are looking for this elasticity. Same when you are using modern Kubernetes application. In a matter of 1 second, you can scale this application and provide more containers for this application. And yet, in front of those very modern applications, you are using an active standby load balancer. Yeah, it does not work. What about the troubleshooting? Well, if you like to spend hours to troubleshoot one application, well, with a legacy load balancer, maybe it's a good idea to continue to use it. But remember what I've told you at the beginning, because of the of the new era that we are living in, plus the change of the architecture in terms of the change of the application in terms of architecture, well, you see that you have more and more application to troubleshoot and to operate. That's why you need to make sure that you have visibility and analytics out of the box. Plus, you need to have a good integration with your infrastructure. So whether you have your on-prem environments leveraging the VMware stacks, or you are using the public cloud, you need to make sure that your ADC, your load balancer, is aware of your environment. Because if this is the case, it's very easy to spin up a new VIP, a new virtual service for your application. We are talking about in matter of minutes and not hours or days. So we are here to show you that the VMware NSX Advanced Load Balancer, previously it was called the AVI solution, it provides everything for managing your application. It is like the glue between your infrastructure and between your application. And it's quite important to have this, because when we speak with different people managing the infrastructure, sometimes they are somehow a little bit blind about their application. And this is what we are trying to do here. We are trying to basically remove the silos that you have in your organization between, the infrastructure team, between the security team, between the application team, and between the ops team. So here we provide this product, and this product is very different from the others. First of all, I want to tell you a little bit about this software-defined platform. But you know what? I will review that a little bit later. So first, I want to tell you about what kind of features we provide with this NSX ALB solution. So it's about local traffic management. So from years, any application had to have a load balancer in front of this application. To do what? To make sure that this application is available, to make sure it can scale, right? And to secure this application as well. We have also these features of global server load balancing, which is somehow the opposite of local traffic management. So we are doing like, you have data center number one, and you want to share the load for one application between data center number one and data center number two. This is one use case of GSLB. Maybe you want to do that active-active, or you want to do that for disaster recovery use case. We have the security use case, right, which is covered by this product. And then we have this container ingress service. That is another use case of this solution, the NSX ALB solution. But one thing which is very important, and one thing that we will review, is about all those features. It provides analytics and observability. So remember what I've told you at the beginning. We want to make sure that you can manage those applications at scale. So we need to make sure that very easily you can get some insight about these applications, right? So why are we different from the others? Well, the answer is very simple. It's because of our architecture. So what we have done since this creation of this product, we have separated the control plane and the data plane. This is what you can see here on this screen. Basically, the brain of the solution, it is called the controller, and the data plane, it's called the service engine, or the application service fabric, as you can read in this slide. So the controller, he knows your environment. That's a key point. Your controller, he knows that you have application or workloads in, I don't know, vCenter on-prem, public cloud, AWS, Azure, etc. So because he has this awareness, he can create dynamically the data plane. So basically, you come to your controller and you say, by the way, my controller, I need a new application in AWS. And because your controller knows how to communicate with this AWS API, it can very easily spin up what you need in this environment fully automatically, fully dynamically. So you end up a few minutes after with a new load balancer in AWS. Or the same is true for your on-prem environment with, of course, vCenter, ESXi, and NSX, for instance. So we have the capability, the controller has the capability to manage the life cycle of the data plane. And that's a key point. Why? Well, it's not because it's trendy to have like a software-defined network where we have separated the control plane and the data plane. It's because it brings a lot of benefits. And I want today to review those benefits with you, just to make sure that you understand the value proposition and how you can benefit from this architecture and from this product, right? So the first thing that I want to tell you is about the fact that this product can run everywhere. This product can be used for any use cases. At the beginning of this presentation, I was talking about where do you have your application. Sometimes the architecture of your application, it relies on bare metal server, VMs, and nowadays maybe containers. The same solution, NSX ALB, same product, one license, one API can be used for all of those use cases, right? So it's not that we have a specific solution if you are using Kubernetes, another solution if you are using a legacy bare metal application, and another solution for VMs. Not at all. It is the same solution. So definitely it simplifies your operations regarding those different applications. So now what are the other benefits and how can I show you that you can benefit from this specific architecture? The first thing is you have your controller here. And this controller is capable to manage application from different cloud environments. And I want to show you that live, right? I don't have a lot of slides. I like to show you a demonstration and directly the UI of the product for you to realize and to understand what I'm saying. So I'm talking about multi-cloud here. What does it mean? Let me go to my other screen here. Give me just 1 second to retrieve my screen. This is this guy here. So this is basically the landing page of one of my controller. And what do you see here? We don't care about the load balancers. We don't care about the data plane. We care about your application. This is why from the beginning, I've told you this product is like the glue between your infrastructure and your application. You have a central location where basically you can see all your applications that you have in your environment. And by the way, this solution is a multi-tenant solution. Here you can see I am within the demo tenant, but I can go to my marketing tenant, to any other tenant, right? And here I have a quick view of all my application. I can click on this plus button, and all of a sudden I know about how this application has been configured. Plus, I know the health of my application. That's very critical here. You want to know if your application, they work properly or not. And just here, I can see that this application, maybe his health of 62 is not very high. I can maybe improve that. And this health score, it's coming from different things, especially from the latency, how fast or how slow my application here is. So I can get those information very quickly. But more importantly, what I want to show you regarding this multi-cloud subject, it's about those 9 applications here. If I click on this button here, I will get more details about those applications. And if you are a little bit patient with me, you will see the same list here, but with more details. And what do you see? You see here, the first one, where does it live? Yes, it lives in VMware. Second application here, it lives on AWS. And the third one here, it resides in Azure. So when I'm telling you it's a multi-cloud solution, here you can witness that. We have one solution, and this solution provides an abstraction layer. This abstraction layer is actually this controller, because the controller, he knows all those ecosystem, all those data center type, VMware, AWS, GCP, OpenStack, Kubernetes, all those environments, he knows how to play with that, right? And here you have an example of that. So one of the first benefits here is you have a centralized location to manage your application. And it's not like you need to have one product for this type of environment like AWS, another product for another environment. No, you can use the same centralized product. This controller can target and can cover many use cases, including different type of environment, as I mentioned, right? So this is basically the first benefit here that you get by using this solution, multi-cloud. What is the next one? Yeah, just before moving to the next one, just wanted to focus a little bit more with the integration that this solution, the NSX ALB solution, has with the specific VCF use case. So here you can see for VCF relies on different VMware products. As you know, of course, we have vSphere, of course, we have NSX, we have Tanzu for the Kubernetes as the modem application, we have ARIA for the operation. And what you can see from this slide is that we have strong integration with those products. Especially think about vSphere. vSphere, we automate how we create the lifecycle of the service engine, especially for a compute and for a storage perspective. Everything is fully automated for you. You have nothing to do. You just tell your controller, by the way, I need a new VIP in this vSphere environment, and your controller will do his magic for you. We have also very strong integration with NSX, when it's about networking, when it's about security, when it's about analytics. Those products, they work very well together. And Tanzu as well. We integrate very strongly with Tanzu. You guys, if you want to see that, I will show you a quick demonstration about how you can use NSX ALB in the use case of containers application, right? So just a quick information about it. What is this second point that we get? What is the second benefit here? It's about elasticity and resiliency. As I have told you, if you guys are still using a legacy load balancer, well, you know how it works. Yeah, it's like 20 years ago, you have your active and standby load balancer. With this NSX ALB solution, it is different. Why? Because again, because of this architecture, your controller knows how to scale. And more importantly, by default, we don't do active standby. We do active. So it means that for one application, you will get 1, 2 service engine, you will get 1, 2 data plane. And the good thing is you can scale this amount of load balancer. It's like exactly the same scalability that you get from your Kubernetes or your modern application. And you will witness that in a matter of seconds, right? And in addition of elasticity, get resiliency. Let's talk about your legacy load balancer. Well, you know how it works. You get a faulty load balancer. You are happy because all the traffic is going to your failover, to your standby appliance. But someone needs to troubleshoot what happened with this active or this primary load balancer. With our solution, we have this self-healing capability. One data plane, one load balancer does not work, we don't care. Basically, the controller will create a new one, and we will use this new data plane to continue to provide the capacity for your application, for load balancing, for GSLB, for security, for your application. So we have this elasticity and resiliency. And here I like to show you one example of that. We are talking about elasticity here. So to do that, again, I will come back to my setup where I have one demonstration ready to show you here. So this is my ALB controller here. And what I have prepared is basically this environment, as you can see. And I have prepared a special tenant here. Right? As you can see here, I am in my admin tenant. I want to move to this cluster 1 tenant because I want to show you something. This cluster 1 tenant it's basically where I have all my use cases for my Kubernetes cluster. And I want to show you two things, how this is very connected with this elasticity that I'm talking about, and how everything is fully automated. So in order to do that, I'm going to show you my cluster. So I have a Kubernetes cluster here. I can show you that quickly. So this is my cluster. You see, I have one master node and I have 3 worker nodes, right? That's fine. You can see also my pods, so my containers in this cluster. You can see that for my CNI, yeah, I'm not using on-prem, nobody's perfect, but I'm using Calico just to show you that we support many other things. And here, what I want to show you is I am an application developer. So I develop my application. I know Kubernetes by heart, and I am just using Kubernetes to spin up a new application. So this is what I'm going to do. I'm going to create a new application here. So I'm going to use this object called a deployment here to create a new application. So now you can see here, it has created 3 different applications, Webfront 1, Webfront 2, and Webfront 3, right? And the services here have been created as well. So this is what my application, application team has done just by using simple, basic Kubernetes API call. Nothing fancy here. And at some point, this is cool. My application is available inside Kubernetes, but let's be honest, we need to make sure that this application is online outside of this Kubernetes cluster. So one of the use cases here is to use an ingress. So I'm going to do here and come and just use this simple ingress .yaml that I have here. And this file is just a very basic Kubernetes API YAML file definition, which we can review just after. So what I'm trying to do is I'm doing this here, and now it says ingress has been created, right? So maybe at some point, if I am lucky enough, as you can see here, what did you see? You see a new object has been created. So what I'm saying here is with this solution, well, even with Kubernetes application, we are we have automation everywhere. So my controller is somehow aware of what is happening inside my Kubernetes cluster. And I can say, I want an ingress, and here it is. This ingress has been configured for you. As I've told you, you can just have a quick look about this ingress YAML definition. It's just a very basic ingress Kubernetes YAML file. You see the kind is ingress. The name is just ingress here. I am defining an FQDN for this ingress. And if I am lucky enough, I would say that this application, if I type /v1, it should go to this Webfront 1, /v2 to this Webfront 2, /v3 to this Webfront 3. And actually, if I go back to my dashboard here, I should see that directly here. You see v1, v2, v3. So what I'm saying here is you can automate, you can benefit from the automation, right? And just for the sake of finishing this test here, let's have a look here, and you see my application is working here, is working there, and for v3 is working as well, right? So I'm happy with that. But wait, we were talking about what? Elasticity. And here I just showed you how you can create a new application from Kubernetes. It's because my next thing here, I want to scale. I want to show you that in Kubernetes, we have this scalability capability. So I'm going to go back to my master terminal here, and I'm going to do something like this. I'm going to say, I want to scale the amount of container for this deployment, not to 2, but maybe, I don't know, to 6 here, right? So I'm doing that. And now you will understand that instead of having just 2 pods or 2 containers here, you will get 6 of them, right? So here you understand we are just talking about Kubernetes scaling capability. You have an application living in Kubernetes, you can scale it. It's very elastic. But again, in front of that, do you think you may install or you may configure an active standby load balancer? I'm not sure it makes sense. You need to have the same elasticity just to avoid to have a bottleneck in front of this very elastic application. And this is exactly what we can do. If I go back to the UI here, what do you see? First, you see that this is no longer 2 pods, it's 6 pods, right? So as soon as we have changed this application in Kubernetes, this change has been replicated to my controller configuration fully automatically. Nothing to do here. What else? Well, now the idea is I want to make sure I have the same elasticity at my load balancer level, right? So if I click on this application here, or this virtual service, as we call it, look what we have here. It says, by the way, you have created fully automatically this object. The name is a little bit weird, but trust me, this is the object that I have created. And you have 2 service engines. In other words, you have 2 data planes for this application. And I want the same elasticity. So what can I do? Well, I can scale out. It's very easy. You scale out, and now you see here it says creating a service engine. So you see here, it's doing the life cycle. It's managed the life cycle of your service engine. And here you go, you have a small error, but I guess it's not a lot. Let's see here again. We have 3 different service engines. So now you get the same elasticity that you have in the cloud, whether you are using VMs or you are using containers. You need to make sure that in front of this application, you have something very scalable. So that was my demonstration number 2. I want you to understand that this value here is unique. And of course, for those 3 data planes, those 3 load balancers here that you can see, we are doing active, active, active. So the load is definitely shared between those 3 different service engines or those 3 different load balancers, right? So if you have any questions, don't hesitate to use the Q&A window. I like to see questions if just to understand if what I'm saying it's clear, or if you need clarification, I will be very happy to cover those questions. What else? Well, we have something else here in terms of benefits, and this is something called automation. And that's a key point here, because what we are seeing, if you are using a legacy load balancer, it's very complicated to make sure that very quickly you can have your application online. Why I'm saying this? It's because we know how it works in organizations where they still have legacy load balancers. You need to configure almost everything manually. Let's say you create an application in a new environment. I don't know, in a new vCenter environment. You will need to deploy maybe a virtualized appliance, and it's going to take a few days. And then when this virtualized appliance is deployed, what will happen? Well, you need someone to tell you which VIP you can use for your new application. And then after, you need someone to configure the DNS server to make sure that with this new VIP, I will configure an FQDN. What else? Well, nowadays, everything is secured, right? So at some point, you will need to add a TLS layer to make sure that traffic is encrypted. So if you need TLS, you will need a certificate. So here you go again, you ask someone, can I get this certificate? And it takes hours, days. So at the end, you end up by waiting a very long time. It could be days, it could be weeks, right? So the intent from the beginning with this product is to make sure that you have everything fully automated. Remember what I've told you. First of all, this controller knows about your environment. So because he knows about your environment, he can instantiate, can deploy service engine, data plane, load balancer fully automatically in any environment. And when this is done, it goes beyond that. Because guess what? The VIP, it can obtain this VIP fully automatically. This FQDN, it can configure this FQDN fully automatically. This TLS certificate, you can get that also fully automatically. So with that, you get the power of automation. But wait, I'm not talking about automation just because we have a REST API and it's very easy to connect with tools like VRO, VRA, Ansible, Terraform. You select the tool that you want. No, I'm talking about this because with this product, you have built-in automation. You have automation that you don't need to do yourself. You can basically say to your controller, this is what I want. And your controller will make sure it will do all the tasks to get what you have ordered. This is exactly what we can provide. And to illustrate this, I want to show you this example. Let's say we have this new application and we need to create a new VIP for this application and to make sure that this application is online. How can we do that? Well, let's go back to the demonstration environment that we have here. Let me go back to my admin tenant here, and let me show you how I can create a new application. So I have 12 applications here listed, and I want to create a new one. Let's see how simple it is. I click to this basic setup here, and first of all, it asks me this question. By the way, I am your controller. Tell me this application. Do you want this to go to this default cloud, which is my vSphere environment? Do you want to go to this other data center, which is a bare metal environment? Do you want to go to AWS, GCP? You understand. First, you need to tell your controller which environment, which location you have your workloads, you have your application. So I'm going to select the first one here, which is a default cloud. And I'm going to say, okay, I want to create a new virtual service. So I give it a name. So let's call this one workshop-TAM here. And of course, I want this to be secured. So automatically, I select HTTPS. It goes to TCP 443, and it allocates this certificate. Of course, I can change if I'm not happy with this certificate. So the next step is, of course, you want to make sure that you can obtain the VIP fully automatically. So here you have this VIP option. So you can create a new one. I'm going to create a new VIP here and see how easy it is. Here you just need to add a VIP. And it tells you, how do you want to get this VIP? Do you want to configure it statically? Well, that's doable, but not very great because you need to find this IP, or you can auto-allocate. And if I auto-allocate, do I want V4, V6, or dual stack? Well, it's your choice. Let's go with a simple one, V4 only. And then what you do is you select the network where basically this VIP will reside, and you select the subnet. And that's it. Nothing else to do. So I have configured my VIP here. I'm going to save this. And I'm going to say, by the way, this VIP that I have configured, I want this to be configured with this DNS name. You see this workshop-tam.vcenter.alb.com, right? This is my intent here. I'm saying in a very declarative way what I need to my controller. I save this, and now I save this screen as well. And now the only thing that I need is just to make sure that I can select the servers of this application. The servers, they can be what? They can be IP, they can be bare metal machine, sorry, they can be a virtual machine, they can be containers, but at the end of the day, for us, it's just IP that I need to configure. It could be IP, it could be DNS name, it could be IP group. You just need to tell your controller where are those servers, right? I have no clue about those servers, but I know that because of the integration that we have, I can directly discover the different networks that we have in this vSphere environment. So I'm going to select, I think this is dev113 in my search bar here. I know that my servers are here in this network. So you see here, now we are discovering all the virtual machines that we have in this network. Again, we can do that because we have this awareness between the controller and your environment. In this case, I'm talking about ESXi vSphere environment, right? So I can select my 2 servers here. I'm happy with that. I add those servers and I save this configuration. And now you see here, this is not working. But if we wait a little bit here, we will get some insight about why it's not working. Oh, the pool, they are not working properly. just because maybe my backend servers are not configured properly here. Let me have a look very quick and let me edit my pool here. I think I know a little bit about this error. It's just because my backend server, again, they are not configured properly. So I guess if I copy this IP address on this host name here, I think it's gonna help. Let me just do the same for my server number 2 here, and that should help to have this application up and running. So give me just 1 second here. Let's save this guy, save that guy, and let's wait a few seconds. So now basically your controller is doing plenty of things. He is checking in this environment, do I have load balancer ready, available? Yes, in this case, I can reuse them. Do I have load balancer, but they are not available? In this case, I can create new ones. So again, here you see the power of automation. And if I need to create new load balancers, what about the network plumbing of those load balancers? You know, I need to configure some virtual NIC. I need to make sure that this load balancer has one NIC in my VIP network and one NIC in my application server network. So all those things, they will be done fully automatically for you. And at some point, what you will see is you will see that your application here is up and running. So you get everything fully automated. But the point here is it's a very declarative way. You tell your controller what you need. And if you remember what I have done, actually, I've just said my VIP network is on the top of this network and on the top of this subnet. Please configure with my VIP network an FQDN setting in my DNS. Use this TLS certificate, and there are the IPs of my server. That's it. So if you guys, you are after doing some load balancing as a service, if you want to make sure that people, they can consume load balancing in your organization, trust me, this product is very helpful. We have plenty of customers who are using this solution just to make sure to provide like a portal, right? And from this portal, I can consume load balancing. And if you need to do that, no need to buy another solution, you know, to have REST API available or whatever. Everything here relies on a REST API. All right, so this is my demonstration number 2 here, and you can see that this application now it's available. So you know what? Let's have a try here. If I just copy this specific FQDN, and let's say I go to my client here. Let me just clean that a little bit. And I am doing something like this. You know, I'm trying just to see if this application works. Let's have a try here. I like to finish what I have started. So let's see here. I paste this here, and you see now my application is working. You may think, well, you see, you are going, all the traffic is going to the same server, which is this .204. True. Why? Because by default, we don't do round robin as a load balancer algorithm. We do a list connection, right? Or list loaded, because we don't want to have this dumb load balancer sending one packet to one server and then the one after to another server, etc. We want to do this in a very smart way, right? So you have the solution here, and you see how easy it is to add basically a new virtual IP, a new application online, just by telling your controller what you need. All right, what is the next and last benefit of this solution? Well, it's about analytics and observability. And this is my favorite one, so I can speak for hours about this one, so I will try to stay brief here, but this is crucial. Why? Again, because you have plenty of applications. So you need to make sure that you have one centralized location where you can see if your applications are working properly or not. And let's say to do that, what we are doing, you have your load balancer. The load balancer is at the middle of between your client of your application and your application server instances. And because of this strategic location, this specific service engine, this data plane, it can see everything. And also because he's acting as a layer 7 reverse proxy, is doing the load balancing at the application layer, he can see everything. And yet, the legacy load balancers, what they are doing, if you need to troubleshoot, well, you need to go and to do a TCP dump, and you need to get this file and to load this file in Wireshark and to understand exactly what is happening. So yes, it works, but it does not work at scale. This is the main difference. And this is exactly what I want to show you now. The benefits that you can get from the analytics and observability. So let me just go back to my environment here, and let me show you a little bit what I mean when I say analytics and visibility. It's about giving you a very precise information. You can see everything, one request per one request, but it's also about providing you some analytics regarding those massive logs that you can have, sorry. And because of this, it is very useful because sometimes you have just one customer. Let's say you have one application and you have enabled a web application firewall, and some customers, they are complaining, now my traffic is dropped, or maybe they are saying, since the security team, they have enabled web application firewall, well, it's very slow, my application. Well, because we have this analytics capability, we can use that as a starting point to make sure we have an efficient troubleshooting journey. So let me show you. If I go to this application here, if I click on it, actually, I don't edit this application if I click on it, but I'm going to open the analytics tab, as you can see. And the first thing, that you can see here is the end-to-end timing. This is very important. Why? Well, you know how it works. I mean, I'm sure you have kids, I have kids. If your application is slow, what do? You leave this application and you open something else. And maybe we are exactly like our kids, right? If you have something that is very slow, at some point you give up and you do something else. And sadly, sometimes you go to the competition. So we know that it's a key for you to have very responsive application. And here it is. You see the end-to-end timing. What is the end-to-end timing? It's basically the sum of the RTT, the round trip time of the client, between the client and the load balancer, the RTT between the load balancer and the server, and the RTT, the app response time, which is the time to build the response. And at the end, you know that basically you have this average end-to-end timing, which is 51 milliseconds here for the past 6 hours. So right now, I have a good visibility of the end-to-end timing of this application, right? But you know, maybe something happened here between 3 p.m. and 4 p.m., right? I'm not based in the US, that's why the time is probably ahead of you. And basically, I want to troubleshoot. Maybe, you know, the application team, they rang me and they told me, by the way, what is happening for my application? I have customer complaining, it's very slow, blah, blah, blah. And you are part of the infrastructure team, network team, whatever. And here you have a legacy load balancer. So you can see the throughput. Do you see something between 3 p.m. and 4 p.m.? Nothing. Everything is flat. You have the open connection. You see something? Nothing. Same for the connection rate. Same for the request rate. So this is crucial here to have this end-to-end timing, because it tells you about the experience of your users when they are using your application, right? And now you may think, well, that's good, I can see the end-to-end timing, but how I can go further? Well, you go to the logs, and from the logs here, you will be able to see more and more information. We have a problem here. We can see so much of information that it's complicated, right? And I'm going to show you a little bit about that. If you are patient with my controller here, is loading basically the log. And I'm loading the logs for the past 6 hours for this application. So I would like you to monitor one number here, this one, 20,000. It's 20,000 logs. It's just the logs that we are loading for the past 6 hours. And maybe we'll continue to grow a little bit later. but it's only for what we call the significant logs. So I'm saying basically, show me all the requests where maybe we think there is an issue, there is a problem for any reason. So you are loading those logs, right? And if I enable the significant and the non-significant log here, maybe you will see the amount of logs that we can record for the past 6 hours. Let's see, let's be patient a little bit with the controller because it's quite a lot to process here. So you see 24,000 logs, but I'm pretty sure this number will increase significantly in the next few seconds, right? So you have all those logs, and that's wonderful. And for each of those logs, you see plenty of things. Look at this one here. I just click on this plus button, and now I can see all kind of information from my client. I know where he's coming from, his operating system, his device, his web browser, his TLS version, etc. You see also plenty of information about the load balancing at the load balancing level. Plus, you see also information from the server. So you have plenty of information that you can use to make sure you troubleshoot this very efficiently. But again, that's almost too much, right? So here, what we have done, we have tried to make sure you can use those logs very efficiently. So if you remember this latency issue, if I want to spot this problem, I have this kind of built filter here, and I can say, okay, my controller, show me the log where app response time is higher than 99 milliseconds. And then I type enter, and now basically you are saying to your controller, show me those logs, right? So let's wait a few seconds here, and let's see what it does. I think, yeah, let's be a little bit patient with my controller. Okay, so let me click here. What do you see? Interestingly, you see a peak of logs between 3 p.m. this afternoon and 4 p.m. this afternoon. So now I'm trying to narrow down this issue. I have the logs in front of me, but still, this is 3,000 or 2,500 logs to check, right? So quite difficult to check them one by one. So this is where you go to the log analytics here and you check. You check, I want to see if it comes from a specific service engine, a specific load balancer. Does it come from a specific one? It's not obvious, right? You have 52% and 48% for those two load balancers. And as you can see here, by the way, you have just an evidence that we are doing active and not active standby, right? So this is not probably a good idea to continue this investigation here. Maybe I can check what are the server IPs that generate those logs. Here, I think maybe you have a good starting point for your troubleshooting, because you see that those logs where the latency is higher than 99 milliseconds, they are all coming from this specific server, this 202 server. So you understand here that it's very easy to troubleshoot the application thanks to these logs in combination with the analytics capabilities that the product brings. And you want to use that. You want to use that for your troubleshooting, but not only. Your application teams, they can benefit from this. They have application, and again, they are a little bit like you. They are blind about what is happening to their application. So they want to see more analytics and more information about their application. For instance, if I just clear this specific filter that I have used, and maybe you want to check, let's say you want to provide to your application team the different response codes that they have for this application. So you see the amount of logs that I have for the past 6 hours. Maybe if I am a little patient with my controller, and if I scroll down here, I can see the response code. What do you see here? You see that you have 200 OK. It's like 82%. of the response of your application. And you have those 404. So those things, they are extremely valuable for your application. And maybe that's something that you want to keep in mind, because those logs, they are good for you if you manage the infrastructure, but they are also very valuable for the application team. All right, so this is a very quick demonstration about the capability that the tool brings because of the analytics. And remember, this is doable because of this architecture, because we have the service engine sending the logs to this controller here. All right, so we are almost at the top of the hour, and I want you to remember 3 takeaways here. We have application everywhere. We have application in any environment, on-prem, public cloud. We have application relying on bare metal server for the legacy application, virtual machines, and containers. And here we have one solution, one unique solution, one product, one license, one API for all of your application. And of course, we have this better together story. It is true, of course, especially with the VMware stacks. If you guys, you are using VCF, which includes vSphere, ES6i, if you guys, you are using NSX, if you guys, you are using Tanzu, ARIA, you understand that we have a specific integration that you can benefit. And it gives you, as an infrastructure manager, all the visibility, of course, and analytics that not only you, but everyone can enjoy. So having said that, I want to thank you for your time today. And maybe we can review if we have questions. This is what I have prepared. And again, thank you for joining this call. Hopefully it was useful and informative for you. Chris?
Yeah, thanks, Nick. This was really great content. We do have a question. I'll just read it here just for everyone. It says that I've been testing Avi in my environment using NSX Cloud, and it looks like only a tier 1 LS, which may be a logical segment, I think, allocation can be done. If I want to use another LS connected to the same T1, it doesn't look like it's possible. The only way is creating a new T1 and connect the segment to that one. Is that by design?
So that's a good question. I think it's related to how we integrate with NSX. And what I want to tell you is usually what we can see here is we have, you can use one transport zone. So I don't know if your LS is a segment or if you meant transport zone, because if it's transport zone, we can use only one by cloud. But I can show you configuration where I have multiple segments for the same cloud environment. If you give me just 1 second, maybe I can show that very quickly, Chris, if we have the time. I believe, let me show you that very quickly. I was not expecting to show you this environment, but maybe
yeah, no
I
problem.
have this. Yeah, okay.
And it does look like LS equals segment is what was just communicated, so.
Yeah, so in this environment here, you see we have integration between the specific controller and an NSX environment, right? As you can see here, I have this cloud environment and the type is NSXT, which means that my controller integrates with vSphere ES6i plus the NSX manager. And if I edit this configuration here, I mean, unless if I miss something during the question, but you can see here that for the data network here, I have one transport zone. As I have told you, you can have only one. And if you want more than one transport zone, maybe we need to create more than one cloud here. So we have workaround. But on the top of this transport zone here, you can see I have one tier 1, which is called tier 1A, and another one, which is called tier 1B. And here I have one segment. So maybe now I understand your question. Maybe your question is, I want to see more than one segment on the same tier 1. I'm not sure if, Leonardo, if you can confirm that. Maybe this is your question. You want to see more than one segment on the same tier 1, I believe. This is maybe your question. And in this case, if you want to do that, that's a good question. I need to, please take this question and, okay, please take this question and we can come back to you. I don't know if, Chris, you can capture Leonardo's detail and just send me a follow-up email. I will double check this to see if there is a workaround to overcome this kind of, it seems to be a limitation, right?
It will definitely do that. And I would also ask, if you follow up with your TAM, they can reach out to us, and we always post the Q&A as well, so that TAMs can follow up. So definitely do that as well.
All right. Anything else? Any other question? That I can see another question. Good. Could you explain the ALB licenses part as well, considering if we have NSXT Advanced or Enterprise license in our environment, we can get ALB Basic license for free. Considering we have more than one NSXT cloud connected to single ALB, how can we utilize the NSXT licenses from more than one NSXT cloud integrated to NSX ALB? All right, that's a long question, but I think I understand the meaning. One thing here, I am not a sales specialist. So first thing is I will give you some insights, but please speak with your VMware sales representative. I don't want to tell you some things that maybe after someone will tell me, oh, this is not right, etc. But let me tell you some guidance. First of all, the license in the NSX ALB, it is based only on the data plane. Okay, so we are talking about controller, you don't have any license. This is free of charge, right? However, for the data plane, and usually this is based on the amount of vCPU or CPU cores that you are using for the service engine, the data plane component. Yes, you need to pay something. If you plan to use something called the basic tier, well, my presentation today was not targeting this tier. I was talking only about the enterprise tier, because the enterprise tiers brings all the benefits that I have mentioned. Elasticity, analytics, GSLB, security, all those features, they are inside the enterprise tier. So the basic tier, it's still available. That's true. That's correct. But the one that we have targeted today is definitely the enterprise tier. So I would like you to double check with your VMware sales representative. Maybe you will probably discover soon that there is a way to get a limited quantity of enterprise license along with your NSXT license. All right, so this is one of my insights here. Double check with your VMware sales representative and ask him how you can get the enterprise tier, because this is where you will get all the benefits of this solution. Again, if you are using the basic tier, that's a good starting point, but you miss quite a lot from what you have seen today.
Thank you, Nick. I don't see any other questions. So we'll just kind of wrap up here again. Really appreciate you taking the time to present here, Nick. This was really great content. And we'll be sure to get the recording link out to everyone. Just to wrap up, as we mentioned at the beginning, this was recorded. The TAM will make it available to you, and we'd like to ask you to join us next month when we'll be looking at how VMware deploys and operates VMware Horizon virtual desktops and apps. We look forward to seeing you for that on July 20th. See you then. Thank you.
Thank you, everyone. Thank you. Bye-bye.
Bye-bye.